Firefighting used to consist of passing water buckets hand to hand. The first fire hoses of the 1600s were made of leather, but these hoses were heavy, would crack when dry, and often break open under pressure. Modern firefighting began with the lightweight cotton fire hose, lined with rubber to keep the cotton dry and flexible. Fire hoses come in a range of sizes to fulfill a range of functions, from small, lightweight ones for fighting forest fires to large, heavy-duty hoses for industrial fires. Production begins with hundreds of bobbins of polyester yarn, feeding automated looms a floor above. A series of spring rods keeps the yarns under uniform tension. This is essential to create a tight weave. The factory programs each loom to weave specific patterns which incorporate identifier stripes. This is a visual guide to help workers assemble the fire hose later on. This woven fabric will form the fire hose's exterior called the jacket. It's got to weather some nasty conditions, so they soak it in a plastic polymer solution with dye for color. The liquid encapsulates the fibers, making them durable and water resistant. At another station, they mix granules of polyurethane, a form of plastic, with white colorant and adhesive pellets. This mixture is for making the waterproof tubing that forms the inside of the fire hose. When they activate the adhesive in the mixture with heat, this tubing will bond to the hose jacket fabric. The mixer feeds the ingredients to an extruder, which melts the mixture and forms it into a hollow tube. The tube then passes through a basin of cool water to set the plastic. Next, the tube goes to the inspection table, where an automated printer prints code numbers on it for tracking purposes. To assemble the fire hose, they first pull out an outer hose jacket over a 33-yard long cable. Then, with another cable, they feed a second untreated hose jacket inside the first one. Finally, they attach a cable to the third and innermost layer, the tube, and pull it along the entire length of the double jacket. Once it's all the way through, they trim both ends. The three layers, outer jacket, inner jacket, and tube, are now ready to become one. They begin the fusing process by clamping one end of the assembled hose to a steam nozzle. As the clamp holds the hose steady, the nozzle blasts pressurized steam into the tube. At the same time, it moves backward, pulling out any kinks. The hot steam melts the adhesive in the tube material, and it penetrates the inner jacket around it. Once everything's perfectly straight, they pump in cold air to solidify the adhesive. This permanently bonds the layers. They roll up the finished hose into a coil, controlling the winder with a foot pedal. Then they lay the coiled hose on a table to install the couplings. Those are the components that attach the hose to the water supply on one end and to the spray nozzle on the other. They trim each end and then insert a brass expansion ring and then an aluminum coupling on top. An expansion machine does the rest. They attach the end securely to the machine's protruding bar. Then the bar retracts and expands, pushing the brass ring outward. The force wedges the brass into the aluminum coupling permanently. This company tests every fire hose it produces under high pressure on this table. After marking the type of hose with a stencil and indelible ink, they fill the hose with water. They check for holes and kinks and verify that the couplings stay in place. After the test, they drain the water. They insert a giant sponge to get rid of any water left behind. And now these new hoses are ready for their baptism by fire.